do we have in the chat in the class right now? Mingje, Oliver, Linda, Brian, Samantha. We have lots of students absent. But nonetheless, just I made an announcement yesterday on the course website that next Tuesday, exactly the same day next week, we are going to have the first guest speakers. She is also Chinese. I just made, I mentioned that on the course website, the name and her affiliation. She is both the professor of math at York University, and also at the same time, she is the director of mathematical finance at the Schulich School of Business. If you want to just become financial engineer, she's also the co-director of the same program, which is a very, I should say, a reputable program in Canada and in North America. She's going to be here to talk, and also she's going, as I said, it's going to be next Tuesday. And as I mentioned that on the website, please don't be absent, okay? And also at the same time, if you have any friends, just also recommend to just provide them the access code to the Zoom sessions and ask them to join, because the talk which she's going to have is very crucial, not only because of the math, but also in case to find your future, I should say, in terms of the career you just want to choose in Canada, concerning how to just, which university is good, what programs is good, and based on the math that you are taking right now at the Berkshire Academy. I 110% recommend you for that course. Then as a result, if you become absent, it's not acceptable. You have to be present on that day, next Tuesday. Then put that on your calendar. Wake up a little bit earlier. If you wake up by 9 and you are in the class by 9:02, please wake up, let's say, by 6 a.m., and get ready for the course then. Yes, everyone is okay now?
Yep.
Makes sense? Then put your alarm clock by 6 a.m. next Tuesday. Okay.
Wow.
And yeah, any questions, guys?
No.
No. And as I said previously, this Thursday is going to be our, I should say, midterm session. Then the same hours from 9 to 11. It's going to be a very easy test. It's very similar to the diagnostic test which you wrote a couple of days ago on the exponential functions, logarithmic functions, but also we include some other concepts like the limits, continuity, endpoint behavior, and those stuff, and some parts of the trigonometry we are just going to cover today then. And that's pretty much everything which I have to say before we start. If you have no questions, I have to turn my laptop upside down to study our first, I should say, attempt to new chapters of the book, which is going to be, which essentially is going to be the topic for the rest of the term until the very last day. You're going to get involved with trigonometric functions, identity, transformations, and cool stuff and applications with that. Then if you have no questions, we just get started. No questions? Okay, let me put my laptop upside down. We can start. Guys, by the way, as I said, I enrolled Sean for this mathematical challenge. I also picked up 2 other of you to enroll you for that challenge, because I know that you have that the capacity to enroll, and you do a great job on that challenge. And also during that challenge, you get the training on how to solve those questions from me. And at the same time, you get the specific training by the professor who's going to talk next Tuesday. She's going to also help you in that mathematical challenge. Then that's the lifetime opportunity. You can involve in a challenge with 2 supports, one from me and one from that professor. It makes sure that you do an exceptional job and you get the gold medal in an international competition. Then I enrolled two of you also in that competition, and I hope that you do a great job. Okay, now let's get it started. It seems that I need my ruler. Let me bring my ruler. Okay. My okay. The pace is going to be a little bit fast because some of the things which you have, which you will see right now, you have seen that in the with the function 11. Then initially we are just going to go move so fast, and I hope that you can catch up very in a good terms with us there. Okay. Okay, let's get it started. Okay. Okay. Maybe the first half an hour of the class is a kind of a review with the things which you had before. Then we just go to the new concepts. Today is going to be, what day is that? Today, April 14?
Yes, April 14.
It's going to be functions, maybe functions. Okay. Okay, guys. First of all, I'm just going to remind you of two facts that you are so familiar with that. You see that maybe there should be some problem to see the circles which I make with this tool because this is the pen, and maybe you do not have enough resolution on my camera to see that. But if I'm using this tool, I'm making a circle. Okay, can you see this circle or no? It's too, you cannot see that, huh?
No, we better use another color, I think.
Yeah, because this is a pencil, unfortunately, and but no worries. Just but remember, the angles which I'm drawing, they are going to be all on the circles. And whenever you see that I'm using this tool, it means that I'm just making a circle. How about right now? Can you see this circle? There's a circle around here. You do not see that? No. Okay, that's bad. But anyhow, this is a circle, and it doesn't matter. I just want to show you the angle. Guys, look at that. Previously, you said that, imagine that this is going to be, I should say, the clock, which you have. And imagine that, for example, I'm just going to draw an angle. So far, based on the things which you learned, on the functions 11, you learned that the angle is an intersection of two straight lines. That's right. As it's a kind of an elementary definition of an angle, which is very suitable for this stage. That intersection of any two lines, straight lines, it creates an angle. Then imagine that the angle which I'm just making is going to be inside a circle, and I use the radius of a circle as two arms of the angle. For example, look at that. This one is going to be, for example, one. For example, I'm just going to start from O. This is going to be the origin. And I'm just going to say, for example, OA is a straight line. And in the circle, which I'm just going to just make this angle, I just say, okay, I just keep OA as a fixed arm. then what I'm going to do is that I'm just going to take this one, for example, have a moving arm. The moving arm goes, for example, to the OB, and I can create the angle, which I name it, let's say, alpha. Uh, but this one, and there is a distinction. This is the thing which you have seen so far. But in trigonometry, which we're just going to focusing for the rest of the term, is that we give the angles a sign. We define positive angles, and at the same time, we define negative angles. What is going to be the positive angles? For the positive angle, like this one, which I have just created, for the positive angle, I said that, okay, this is going to be, for example, from A to B. If the distance between A to B, which is going to be on this arc, which is a part of this circle, if the distance between A to B is counterclockwise, for example, imagine the arms of a clock that they just rotate around this direction. But if the distance between A to B is counterclockwise, it means that the angle which you are defining is going to be a positive angle. Then I just call that A, alpha, is greater than 0. It's positive. But at the same time, as a contrast, imagine I'm creating another angle on the other side of the circle, and I say that, for example, the fixed arm is going to be, for example, C, OC, and for the moving arm, I'm going to put the D here. And the way which I'm creating this angle, if you see, from C to D, the displacements on the curve, on the arc of a circle is going to be clockwise in the direction that the arms of your watch, of your clock, moves and rotate around the center of your watch. Then I say that the CD, if I call that with the angle like beta, beta is negative. That's a negative angle. That's, you have seen that in your functions 11 course. It's a kind of a reminding you that also for functions 12, when we talk about the angles, we have two distinct type of the angles. The positive angles, which shows that the rotation of the moving arm of an angle counterclockwise, and also we have positive negative angles, which it shows that the rotation of the moving or rotating arm of an angle along the curve and along the arc on that circle is clockwise. Then we have two type of the angles. Okay, that's the thing that we discussed. Any questions so far? That's the thing which you have in function 11. No questions, guys?
No.
No. And now, another I should say,
What did I learn in function 11? I just learned it brand new.
Sorry, what?
I said, what did you guys learn at function 11? It just like, to me, it's brand new.
Oh, okay. Oh, but you had more advanced stuff, and it's good. Brand new but easy stuff, huh?
Yeah.
Awesome. Okay. And now, the other thing which you have, the thing which I'm going to talk is that thing. And also this is from function 11 course. In the trigonometry, but before trigonometry, in geometry, for example, in geometry, we used to just build structures like this. We used to build the structures, let's say, like a triangle. I'm making a triangle, and you see the triangle which I'm making, I call that A, B, and C. And the triangle, guys, which you will see I'm creating there, it's we can see three angles because I have three distinct intersection of the lines. For example, alpha, I call that 30 degrees. I have A, I call that, for example, let's say 70 degrees, and C, I call that, for example, how much? How much that going to be? Guys, are you still there?
I can't see.
How about now?
30 and 90?
70.
70. Then it's 80.
80, that's right. Guys, please just give me a hint whenever either I'm just out of the window or you do not see because of the lighting. Still, I'm trying to buy some stuff, but stables and future shops, they're all closed. And now, this is the thing which we discovered on the geometry, but in the trigonometry, we do not use angles anymore. We are just going to use another scale to measure the angles, and that scale is it is called the radians. What is a radians? I highlighted that on Thursday before we leave the sessions. We said that if we have an angle, I create an angle. I call the angle, let's say, alpha. Can you see that, guys?
Yes.
That's right. And I create an angle which is alpha. And the alpha is subsecting two parts on my circle, and it creates an arc. The circumference of the circle, which is confined by by my angle, and you will see that I call this from, for example, from A to B, and that's going to be the arc. And the thing which we saw before in function 11 was that for this arc, because it's part of the circumference of this circle has a radius of r. But if the radius of r, what is the circumference of this circle, guys?
I don't understand. Can you repeat that again?
What is the circumference of the circle? I mean the length of all the arc around that circle. 2 pi times its radius.
Okay. Yeah, sorry. Yeah.
No worries. That's right. And that becomes a circumference. When you make, for example, imagine that's a birthday cake. And you have, for example, this is, let's say, for example, this is Brian's birthday. And Brian has sliced the cake of this size for Sean, for example. And you say that if the arc, the piece of cake, which is sliced by Brian, which is from A to B, the length of this, we call that arc. If this is equal to the radius of this circle, I mean if AB, which is an arc, that's why I show this symbol on top of it to show that this is the arc. If the arc is equal to the r, the radius, then as a result, we call that the angle which we have created, alpha, is 1 radians. Correct?
I still have trouble to understand. I'm sorry. So basically, is like alpha equals to what?
Alpha equals to alpha.
Alpha equals to 1 radians. It's equal to 1.
Oh.
And let me explain once more. But you have no difficulty to see what I have drawn here or what I have written here, huh?
Oh no.
Alpha equals to 1. R should be equals to 1.
And guys, look at that. I'm going to explain once more. Imagine that this is a circle which I have drawn. And in 2 seconds, it should be clear for you that why we do use circles when we want to assign and when we want to define the angle. It should be clear to you in 1 second. But before we get there, I'm saying that if I have a circle, which I know the circumference of that circle is how much? 2 times pi times r. That's the circumference on that circle. Then I say, I come to slice. Imagine if that circle, it's a kind of a birthday cake, which is for Brian's birthday or David's birthday. And we say that if we cut this cake and just remove and slice from this cake in a way that the arc which I have created, which means that this is the cake at the outer piece, which is from A to B. This is called arc, and you can measure it. Yes, Samantha?
Yes.
It's a part of the circumference. For example, the arc can be 1 meter, 2 meters, 2 centimeters, or 7 millimeters. That's the length. The unit is the length of the arc. I say that if the arc, which is the sliced part of this, I should say circle, which is a birthday cake for our example, if this arc AB, its length is equal to the radius of that circle or that cake. For example, if the radius is 7 millimeter or 7 inch, for example, and the arc of this slice of the cake accidentally becomes 7 inch, which is equal to the R, then we say that whatever angle is looking at that arc, imagine that between OA and OB, there is an eye, and that eye is looking at the length of the arc in front of itself, huh?
Yes.
Then we say that in that exceptional case, that the length of the arc is accidentally equals to the radius of that circle, R, then we say, okay, the eye which is looking at the AB, which is the angle, we call that it is 1 radians. It can be 20 degrees, it can be 50 degrees or anything. But it is, in terms of the radians, it is 1 radians. That's right?
Okay. Is like 1 radian. I'm sorry, I have so many questions. Like what 1 radian stands for?
So say that again.
What 1 radian stands for? Like the part I don't understand
It's
is
a Greek word. It's from the radius. Radius means the radiance. For example, the R, that's why we call that R, the radius of a circle. The
yes.
distance between the center and the first point when you intersect on the area of that circle. That's radius. You know what is a radius, huh?
Yes.
That's
But okay, so tell me if I understand it wrong. So is like AB this length equals to R, and then when the R equals to AB, and the alpha equals to actually R. Like,
That's so true.
No.
Huh?
A little, you are so true as Sean mentioned, but a little bit adjustment it needs to be done. We said that the alpha, if the condition is met, that we say that the length of the arc is accidentally equal to the radius of that circle, then we say that the angle which is looking at that arc is measured as 1 radians. That's the building block, that's the unit of the angles. And why do I say that? Because if we have been working with the degrees so far, for example, we see that the triangle, in a triangle, which we mentioned that so far, one of the angles is 30 degrees, or one of the angle is 80 degrees, we are not gonna work anymore with the degrees. We are gonna create a new measurement of the angles, which is called radians.
Oh, okay.
Imagine
Now
that you want to go to a party, you want to design a new costume. And by doing this, Samantha, we are designing a new method in order to measure the angles. For example, when we define, for example, the angles, for example, when you define the degrees, how did we define the degrees? We said that, okay, if you have a straight line, for example, from A to B, we define that from A to B, you can just define an angle which is going to be divided by 180 equal distances, then project them onto your circle, then it becomes the degree. then that's how the degree is created. And that's how we define, for example, when we work in geometry with an angle, that's how we use this definition to say that, for example, this corner, this angle is 80 degrees based on this definition. And the thing which we are doing right now is that we are trying to design a system. To design a system that we create a new custom, a new method to measure the angles. That is what we do. And in order to design it, we say that one rate, for example, we said 1 degree is 1 out of 180 on a straight line. That's right? That's how define the degree. But in order to define the unit of a radians as a new system to measure the angles, we design like that. For example, that's a custom designer. We say that it's defined on a circle in a way that if you have the radius of the circle and you cut the radius from A to B, accidentally, if AB, the length of the arc, equals the length of the radius of the same angle, the same circle, then the angle which is created by this arc, or it's watching the arc, it is defined as 1 radians. That's how we define degree, that's how we define radians. There are 2 different systems. It makes sense?
Yeah, it makes sense. Thank you.
Awesome. Anyone has any question? No. Okay, and now, then as a result, guys, if we say that, it is very crucial because please listen to every single second of the class, because the things which you learn right now is the building blocks for whatever you do in the future. Then don't be shy. If you have any questions, please ask it. Otherwise, in future, there are so much difficulty in any discipline. And now, guys, I said that if I defined 1 radians, but on a circle, how many radians do we have? I repeat my question again. That's how defined 1 radians.
Okay.
When the piece of the arc, I emphasize the piece of the arc, which is a fraction of the circumference of the circle. If this one is equal to the r, we have 1 radians. How many radians do we have on a circle?
2.
2.
Oh, no, sorry. Infinity is like a lot. Like, but they're all equals, but they're a lot.
That's a very philosophical answer. There is a need for a philosopher to when you talked about the infinity, it becomes very deep. It becomes very deep. But let's see how the others answer it. Guys, how many radians we can fit inside the circle? Hello? Who is there? Please say your names, guys, if you are there.
Brian.
Huh?
Minji.
John.
Okay, how about Oliver? How about Linda? Okay. Guys, Minji, Sean, Brian, Oliver, David, Linda, Samantha answered. What is your question? What is your answer? How many radians can I fit inside a circle based on this definition? No one wants to answer?
2 pi.
2 pi.
Yeah.
We have the second answer, 2 pi. How about the others?
Sorry, what's the answer? Oh, what's the question?
The same question which you answered. How many radians can be fit inside the circle?
Infinity.
Infinity. You have infinity. We have 2 pi. The third answer. No one?
1.
1 from Sean. And that's all. How about Linda, David, Brian, Oliver? Okay. Let me answer it myself. Help me, guys. Help me to understand it, because I need your help to figure this out. That's the problem of the century. Look at this. Based on the definition that we had, which we had, guys, it is very important. Based on the definition which we had, we said that if this arc length AB equals to the R, then we have 1 radians. That's right. Then the crucial thing is that we are talking about this AB, which is a fraction of the circumference. Then in order to see how much radians do we have, what do we do? For example, imagine that I say that, guys, everyone is there?
Yes.
Sean,
Yeah.
are you living close to the school, close to the Berkshire?
Yes.
Yeah. For example, I said that, imagine the distance between Sean's house to, let's say, to the Berkshire Academy is 10 kilometers. Okay. Then I come to say that if Sean wants to walk, his step, each long step is going to be 1 meter. Then how many steps Sean can fit in the distance between his house to school, regards to the fact that his step length is 1 meter? What do you do? The Sean's house distance to the school is, let's say, 100 meter. Sean's step is 1 meter. How many steps can you fit into that distance?
100.
You say 100 divided by 1 step, huh?
Yes.
And look at this one. Imagine that. The question which we asked for Sean, it was a straight line. But now we put it in a circle. It doesn't matter. We are looking for the length. Either it's going to be straight or it's going to be a circle. For Sean's case, we said that the distance between Sean's house to the school, 100 divided by Sean's step, which is 1. In this case, we say that, imagine the point A is the Sean's house. Sean walks along the circle, comes back to the point A. How much distance he has walked?
100 meters.
No, if the radius, that's right. But if the radius is R, how much distance?
Oh, 100 divide, no. R divided by 1.
You are getting so close, but forget about that 100. And now focus on this one. That it was my mistake. I should have said that the previous example is over.
Oh, okay.
I should have said,
I'm
guys.
sorry, I'm just not. I'm trying to answer the questions.
No worries.
Put me back into the mood. I'm not quite into the mood.
No worries, because it was my mistake. I should have said that, guys. The previous example, which is the Sean's house to the Berkshire Academy, 100 meter, is gone. It's done.
Oh, that example is so fascinating. So we do not want to leave it.
and now we go to the second example. We said that, imagine point A on this circle, it denotes where Sean's house is located. If Sean starts to walk counterclockwise along this direction, goes to point B and walk all the way around the circle, and comes back again to the same point, goes back to house, point A. How much distance he has paved if the radius of that circle is R?
So basically what we know is like the length A to B is R. So I just need to define like, oh, okay, so like we know about the alpha, so use
No, even do not think of the alpha. Forget about
okay.
the alpha.
Uh,
From A, you walk all the way counterclockwise, come back to the A again. How much is the distance you have paid?
yes, I learned it at preschool, but I don't remember right now.
No
Oh,
worries.
the the teacher just taught us about this concept.
Oh, 2
A
pi.
equals to 2 pi r. It's just writing on the paper.
That's right.
I'm sorry, I'm just
You-
being stupid.
No worries. Guys, it's to be honest with you, how many days we had off? We had Friday, we had Saturday, we had Sunday, we had Monday. I'm not still sure if I can just teach. It was such a long way not to just work. No worries, your brain is warming up.
Yeah, I'm sorry. I'm just keeping asking questions because
No
I
worries.
can't stop looking at my phone. Like when I asking it, I don't look. So that's the reason why I'm just trying to ask.
No
Oh,
worries. Asking question is always good. Then the thing
oh
is
my
that when
god,
you
I'm
walk,
so stupid.
no. Don't say that. There is no stupid questions. In the class myself, I had a class yesterday myself. It was by the Zoom. I asked lots of questions that the prof said that why you do not stop asking questions. He got tired from me. Then always ask questions. Then it means that when you walk from A, go all the way back to the A, you are on the circumference of the circle. Then the distance which you take is 2 pi r. Then I ask you how many radians you can fit. If you assume that the length of that piece of length equals to the r becomes 1 radians, then you say that in order to see how many radians you can fit, that fitness problem is like the example which we had for the Sean's house. Sean's house distance to the school is 100 meter, each step is 1 meter. Then you can fit 100 meter, like this one. The total distance of the house to the Berkshire Academy is 2 pi r, and you see the r, it's going to be the distance that the Sean's step is divided by the r. That means that 2 pi, as Mingje said, is going to be the total number of the radians that you can fit inside a circle regardless of how much is the length of the radius. Good, guys? So far, so good?
Yeah, so far so good.
Awesome. Okay, now.
Oh my god, this is hilarious.
Somebody said something?
Yeah, I said that's hilarious. I just took time to read the formula you just wrote.
You can read it?
No, it's okay.
No.
It doesn't matter. Yeah, I can read right now.
Okay, now, the thing is that now, before we just go for the first break, we learned that, guys, so far, that how we can design a new system, we designed a system now that by using that, we can measure the angles not by the degrees, but also by the radians. Then, imagine that. Let me make another circle. Let me have another circle. Okay, now. Okay, now. We are just not going to talk about the fact that, for example, if this is going to be the circle with the point O, and I touched that topic, I should say, before we just go on Thursday. We said that from now on, I'm not going to prove this here for you, then you have to just find a method in order to convert between the radians and the degrees. And the formula which we're just going to use for that is this. We are going to say this one. Give me 1 second to see if I can show that something to you. Okay. Look at that. I'm just going to make a very simple diagram. Make a simple diagram. And guys, look at that. We said that. Then we have the radians and we have the degrees. Then how much radians we fit inside the circle? 2 pi, huh?
2 pi.
Previously, you learned how much degrees is that? A circle, around the circle, how much degree is that?
360 degrees.
That's right, 360. Okay, then for example, we are in a situation that, for example, we have an angle like this. We know the arc length, and now it doesn't matter how much is the radius, because you saw that in the conversion to the new system to measure the angle, despite the fact you need the radius to define the radians, you do not need that anymore, because you saw that inside any circle, regardless of the radius which it has, you can fit 2 pi radians, and it's independent of the r. And now, based on the fact that you have seen, I'm going to drive a formula which is going to be very handy for the rest of the term. Please make sure that you just write it yourself. We said that if 2 pi is going to be fit inside the circle, this 2 pi represents 360 degrees inside the circle. Then I say that, for example, if I give you, for example, 20 degrees, how much radians is that going to be? I called it x. How much radians is that going to be?
2 multiplied by pi.
That's so it's a simple now. It's a simple proportionality constant. How it works? I say that x, which represents my angle in degree, equals to what? Equals to
So is x equals to 20 degree, right?
That's right. It equals to 2 pi over 360 multiplied by 20 degrees. That's right. It's a simple proportionality. You said that x is equals to the multiplication of these two parts divided by this. You have seen that before in the elementary math, huh?
Yes.
And now, then as a result, I'm just going to divide this system. We said that degrees give me 1 second, guys. We say that what? We say that the radians it's equals to pi divided by 180 times degrees. That's what we are gonna drive it now. That in future, in future, when we just want to make some conversions between different angles, we use this definition, that the radians equals to pi over 180 times the degrees that you have been given.
Questions?
Yeah.
Why 180? I know that's a stupid one, but why you use like 360?
Yeah, sure. Because I just wrote this formula based on the things which I had before. I had 2 pi divided by 360 times 20 degrees, and I just had 2 removed from this one pi, and 2 by 1 becomes 1.
Okay. Oh my god, I shouldn't ask.
No, it's totally fine.
Don't think less of me if I ask those kind of questions. I'm just not in the mood. I will just bet too much.
It's good to ask questions because it's good that I see that some people are listening and it keeps me moving then. Okay, now. Okay. Now, before we go for the, what time is it, guys?
9:58.
9 what?
9:58.
9:58. When we come back from the break, we have to keep the paces a little bit, I should say, faster. But before we go, in order to do some practice, which is going to be chapter 6.1 of the book. The thing is going to be chapter 6.1.
Sorry, can you flip back to what for just for 1 second?
Yeah, sure.
Yeah, just hold on 1 second.
You're fine?
Yeah.
Awesome.
Yeah, got that.
Awesome. Guys, before we move on, I just want you to give you an example. You do more practices yourself from the chapter 6.1 and 6.2. I'm going to assign those exercises for you because from now on, when you are in the trigonometry, your exercises is going to be continuous and it's mandatory because you need more practice with the trigonometric function. Then you have to do the exercises. But before we leave for the break, I give you some angles. I just give them some of them in radians, some of them in degrees. You just find the conversion into the other one. I call this one radians, and I call this degree. We start from the first angle, 0 degree. Let me do this. Okay. Let's do some angles. 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. And I think that's much because I need these angles to show that to you when we come back from the break. Guys, can you please use the formula which I gave to you to find the radians conversion of these angles in degrees? And remember, the formula is pi over 180 times whatever you have in terms of the degrees. It gives you its radians.
Mhm.
Guys, any questions?
No, it's okay.
Okay, how much is the radians, the 0 degrees?
0.
90 degrees.
Not done yet. Wait.
You put 90 multiplied by pi over 9, 180 becomes pi over 2. How much is 180? Sean, Ming-J, Oliver, Samantha, David, Linda.
3.14, but which is pi.
For what, 180
Yeah.
becomes pi. How about 270?
4.71.
No, 3 pi over, no, which one? For 270.
270. Yeah.
How much did he get?
4.71.
Say that again.
4.71.
You mean 4 pi?
It doesn't matter. It's okay.
No. You say that pi times 180 times 270. The common factor
Pi actually.
the common factor is going to be 90. 90 it becomes 2,
Yeah.
it becomes 3. Then we are left with 3 pi over 2. Correct?
Yeah. Oh, okay. You don't. I thought we're gonna put pi into numbers.
Oh no, don't do that in the radians. With the
Okay.
radians, keep the pi there very to that because we keep the pi.
Okay.
And for 360 becomes how much?
3 pi.
You mean 2 pi, huh?
2 pi. Sorry.
That's right. Okay, now we're just gonna take the break. It's not essentially right now, guys, from the book, from the Nelson's book, we just covered for this, I should say, almost less than an hour, which we had. We covered chapter 6.1. Then it means that, please, today, when you are done with the class, okay, the exercises, which is going to be for chapter 6.1, which is going to be exercise from 1 to number 16 is going to be, no, until 14. 15 and 16 is more advanced. You do not need to do that. But it means that when we are done today, chapter 6.1 is fully covered of your book. And the exercise of the chapter 6.1, 14 exercise becomes your homework for tomorrow. Okay? Awesome. Awesome. Now, guys, we take a break as we finish chapter 6.1. Any questions, guys?
No.
Thank you. Anybody else? Guys, say your name if you are there.
Samantha.
Minji.
Sean.
Ryan.
And Oliver, David. Okay. Now, guys, just what time is it now?
6:10.
Okay.
10:06. Sorry.
Yeah. Then, guys, please come back in 10:21. Huh?
Yeah.
Then we continue with chapter 6.2 of the book. Okay. See you guys soon then.
Okay. See ya.
See you later. Hello, guys. Are you back? Hello.
Hello.
Okay, now let's move on to some new topics. We have to just go a little faster.
Hey, Omid,
Yes.
the light is a little bit too strong, like it hurt my eyes.
Is it good now?
Yeah.
Awesome. Okay, now everybody's back. Linda, I noticed that you had raised your hand because my laptop is upside down. I couldn't see what's happening on the chat. Linda, are you there? Linda? Okay, now let's move on. Guys, please stay with me if you have now, I should say, we have lots to cover for this period. Please, if you have 2 ears and 2 eyes, please borrow 2 more because this is going to be very crucial for the rest of the sessions which we're going to have. Guys, so far, what did I do? So far, the thing was that I just talked about the angles. But anyone can see the paper right now? Is it good?
Yes.
Awesome. Guys, look at now. This part is going to be very crucial, and anything we're going to talk about that for tomorrow is built on today's lecture. Look at this one. Now that I know about the angle, I'm just going to talk about the trigonometry and the origin of that. Look at that. What I did right now here is that I created, I should say, I designed a Cartesian reference frame, a normal one with the x and y, I should say, coordinates. And I know that from my elementary math that any point in the plane of x and y has 2 unique and specific coordinates. That's right. That's what you have learned, correct?
Mm-hmm.
And now imagine that. Now I'm just going to combine on the origin of my Cartesian reference frame. I'm just going to draw a circle which its center is coincident with the origin of my Cartesian reference frame. I hope that you see the angle, you see the circle, but imagine that I'm just drawing a circle which this circle, its center is coinciding with the center of my Cartesian frame. Okay, and now we're at this stage. We didn't do anything except we draw some geometrical shape. And now, the point here is that, guys, right now, I just, from now on, from the rest of the course, I'm just going to assign some points still inside this plane, but I can find my points to be on the circumference of this circle. For example, here, right?
Mm-hmm.
Then from now on till the end of this course, I'm just going to confine myself only with the points in the plane, which these points are on the circumference of this, I should say, the circle. Then I do not have any points outside or within that circle. If that thing happens, something also different is going to happen. If I didn't have the circle, it was evident for me if I want to localize this my point there, I had the coordinates x and y to identify my points. But right now that my point is on the circumference of that circle, I have additional coordinate. If I call my point, for example, I call my point S. My point S has now 2 addresses to get there. For example, you are anywhere, you are at the origin of this Cartesian coordinates. In order to find point S, you have two addresses, two ways to localize your point. We're going to talk about this now. How is that possible? The first thing is that because my point is on the circumference, based on the things that you learned before we go for the break, you know that my point S here is characterizing an angle, a positive angle. That's right. That's a positive angle. This is going to be this point. And I call the angle which it's creating, I call that point alpha. It can be anything. And I know I learned so far how alpha can be expressed in radians. But guys, one of the most important things that we are going to see in this trigonometry is that because of the symmetry which a circle introduces into the plane, point number S has at least three other points which they behave exactly like S itself. Imagine that S is going to be, for example, Mingje. Mingje, are you there?
Yes.
Imagine Mingje is standing at point S. Mingje, you are going to find three other Mingje, which they are exactly like your twin brothers, and they behave exactly like you. I mean, when you laugh, they laugh. When you cry, they cry. When you walk, they walk. It means that the behavior characteristics is going to be exactly like you. Okay, that's because of the symmetry of the circle inside the plane. How do I find those three other Mingje? At this stage, before we do anything else, I use my ruler to find these three, but later we define some characteristics for that. The first Mingje, which behaves exactly like Mingje, is gonna be, I just make a parallel line with the point, with the axis X. The first intersection on the circle, it becomes another S. Okay?
Okay.
From that point on the circumference of the circle, I project it downwards parallel to the y-axis. I find another point. Let me change the color. I call that another S. This is another Mingje. And again, from that point, I take my ruler, make a parallel line with respect to the x-axis, and I make a parallel line like this, and I go all the way here until I intersect, make an intersection with the circumference of the circle. I have another point S. And also you see that if you move up, you get back again to the Mingje, which we started with. Mingje, if you are standing there, correct?
Yeah.
The other Mingjes that you find by this method, they are behaving exactly like you. If you decide right now to run, they run with you. If you want to laugh, they laugh exactly like you. I mean that the behavior characteristics is exactly like you. They are like your mirror images. Huh?
Okay.
Okay, now, everyone got this point?
Yes.
Yes? Awesome.
Yes.
Now, in order to find, now, what is the goal right now? The goal that I'm just gonna follow right now is that for these other Mingjes here, there are at least three. You can find many, infinite number of the Mingjes, which they behave like that. That's what we talk about, the periodicity of these functions. We're gonna talk about that later. But at this stage, we learn that because of the symmetry, they have three other Mingjes with the same behavior as Mingje. Now, the next 5 minutes, I'm gonna talk about how to localize them, how to give them the coordinates. In order to give the coordinates to this, imagine Mingje at this point. Mingje is at my first coordinates, correct? First quadrant of this Cartesian reference frame. If I put S, because it has a project on the x-axis and it has a project on the y-axis, correct?
Correct.
Then in that sense, I can localize that point with the Cartesian coordinates x and y, correct? I do not look at the circle at this stage. I say, okay, I have a point, regardless that this is on the circumference of the circle, I have a point and it has a coordinates x and y. I put it there, correct? And now, if this is x and y for Ming-J, it's 2 and 3, for example. What is the other one? At the second quadrant, by using the symmetry, x and y is going to be the same, but imagine x is now at the second quadrant, x is minus,
So
x
it's
becomes
minus
x. That's right, and plus y. How
So
about the s at the third quadrant?
it's minus x minus y.
That's fantastic. Minus x minus y. And how about the Ming-J's coordinates at the fourth quadrant?
X minus y.
That's right, x minus y. For example, imagine that if x is 2, y is 2, then it becomes minus 2, 2, minus 2, minus 2, 2, minus 2. You see? Then you start with 1 point and you know always the coordinates of the other brothers. I call them brother point. Huh? Okay. Any questions so far?
No.
No? Okay. And now, it was the first stage to identify these points. But the second stage is that, guys, I just want to see the effect of the circle. Because when I have a circle, I always have the concepts of that angle. But right now, my circle is joined with the Cartesian frame. It means that for any points on the circumference, you have now two identities. One is going to be Cartesian coordinates. The other one is the angle. For these broader points of the Ming-J, I was able to find the Cartesian coordinates. How about the angles? In terms of having the angle, how can I identify them? For this point at the second quadrant, in order to find the angle, I think that I imagine that, guys, that this one, the x one is gonna be my fixed arm. I keep it fixed. Then in order to identify the angles, the moving arm is gonna join to the point S. Correct? Then it makes this angle. The angle is gonna, can you see this color?
Yes.
Yes. Then the angle is gonna be between this and this. How much is that gonna be, that angle?
Is 45 if you divide it like evenly.
No. There is no number.
Oh, okay.
You have to express the alpha.
Wait, just hold on a second.
Linda, David, Arya, Mingje, Sean.
So is pi over 2 because this one is 90.
Pi over 2. You are getting close, but not yet there. Guys, look at that. Mingje, do you know that?
Is 180 minus 2 alpha.
180 minus 2 alpha. You are getting so close, but not there yet. Look at that, guys. This, because we talked about the symmetry between S and S over here, and if this angle, which is alpha, which is highlighted by the orange color, the angle from here is also, you see this angle?
Yeah.
It's too vague. I hope that you see that. This angle is also alpha because of the symmetry. This angle with this angle is the same. If the angle between this point and that point is 180, then the angle is gonna be 180, which is the whole angle, minus this one, which is not included on this. Then this angle becomes pi minus alpha, right?
Okay. Oh, you use it. Okay, whatever.
pi minus, I wish if I had a bigger circle, it seems a little bit small. Okay, this is the first angle that is found. This angle, it becomes pi minus alpha. Then guys, you see that if Ming is gonna be standing here with the coordinate x and y, his first brother, which exactly behaves as Ming is gonna be minus x and y, or by the other reference, if Ming is reading the angle alpha, his brother who behaves exactly like Ming his angle is pi minus alpha. You got it, guys? Now, I'm gonna go to the second brother of the Ming which behaves like him. The second brother, it's gonna be very easy to localize it. I say, if the fixed arm is gonna be this, then this moving arm is going to go to the point S over there. Then the angle becomes how much? You see the angle? Everyone can, or is it too small or you can see that? Guys, is the size okay?
Yes.
Awesome. Okay. And now I'm going to the another Ming. Okay. As Samantha said, the other coordinates of the Ming, it's minus x and minus y. But how about the angle? Use a symmetry which is introduced by this circle. You see that here. If they are symmetric, these two lines are on top of each other, correct?
Mm-hmm.
I'm not going to draw it here. Look at this. This line, I'm going to draw it like this. I need another paper. Let me show that on a paper, which I do not need that. Look at this one, guys. If I have an angle like this, a line, and a line like that. If this is alpha, how much is this angle? This is alpha. How much is this one?
Alpha.
Alpha. So true, because that's the basic thing that we know from the geometry. The same thing is there. Why? Because look at that. The same line here, and these lines are in the same. That's exactly like that. If this is alpha, how much is this angle? I mean this angle. This angle is alpha itself, huh? Like this, correct? Then, if from here to there, this is because of a straight line. Straight line means pi radians or 180 degrees. Then when you get there, you have to move from here to there. It means that from 180, which you had to add also alpha there to get to this point, to another Ming, which it means that this angle is going to be what? It's going to be pi plus alpha, which it means that if Ming, which standing at point x and y with the angle alpha, he can find his second brother at the point minus x minus y, which his angle is pi plus alpha. If x is 2, y is 1, for example, another brother becomes minus 2 minus 1, or if the angle which Ming has is 30 degrees, the angle is going to be 100 plus 30 degrees, becomes 210 degrees then. That's right? Or pi plus pi over 6. Correct? So far, so good, guys. Any questions? I'm going to stop here in case if you have any questions. Hello?
Oh.
Are you still there?
Yes, yes.
Okay, any questions?
Not really.
Okay. How about you, Mingje, Oliver, Linda?
I do have a question.
No
Anybody has a
question.
question?
Don't make that sound,
No.
John. That's so disrespected. You can't disrespect stupid
no.
people.
Okay.
No worries.
Do you have a question?
Guys,
Yes.
everyone is very smart, but we have to ask questions to become smarter.
Okay, so I do understand the second one, but I don't understand the first one.
You mean the first one? You mean this one, pi minus alpha?
Yes.
Okay.
Like why pi minus alpha?
Because let me draw it here. Let me draw it here. Imagine the first line which I have.
Yeah.
I'm just gonna draw this line here.
Mm-hmm.
How much degree is that?
180.
180. And also let me also draw the other line, which is gonna be the y-axis. This is my y-axis. This one is alpha, and also because of the symmetry, if this is alpha, this one is also what? Alpha.
Yes.
Correct? Because of the symmetry, because of the circle around it. But we are looking for what? We are looking for this angle from here to there, correct?
Mm-hmm.
Okay, and now, Samantha, if I want to move, the angle moves from here to there. I mean, if the moving arm, imagine that this is my finger on this, huh? You see my fingers on top of the moving arm?
Yes.
If my finger push it, become down, go to this point, how much is the angle from here?
180.
180.
Oh, okay. Yeah.
But I didn't push it down there. I lack alpha degree to become to the 180. My fingers are stopped there. I didn't just pass the way for alpha degrees. I got stopped there. Then how much is the angle from here to there?
From here, where to where?
Huh?
Then it's pi minus alpha, right?
That's right.
You just-
Because pi is the total of this, 180, but
Oh,
I miss alpha to get to the pi. Then I remove the alpha from it.
okay. I know where's going wrong here. Okay, Linda sent to you a two message. Like, she said, her network is slow. So when you call her, she doesn't mean to didn't answer it. Okay, I don't know if that's something she want to say, but I think.
Okay.
Yeah.
Okay, I understand. Okay, thanks for reading that message because I do not see my message box there.
No
And
problem.
Samantha, you got this point, huh? What
Yes.
happened in the first angle?
Yes.
Now, for the fourth brother of Mingje, which the coordinates is x and minus y, if I want to express that by the angle, what happens?
She said, sorry. Oh, I thought. She said, she can hear you, but you can't hear her.
Okay. No worries. I hope that she's doing fine.
Yeah.
Great. And now, guys, look at this. And now, in order to get to the fourth point, I have x minus y. And now, in order to express the angle, how much is the angle is going to be? Mirjay says that, okay, I'm reading the angle alpha, coordinates x and y. Where is my fourth brother? Mingje, I'm asking you directly. Where is your fourth brother?
Is 2 pi minus alpha.
Oh, fantastic. That's great. Then this angle from here, it becomes, if I show that, it becomes too messy. This angle becomes, let me write that with the black, different color, 2 pi minus alpha. I wish if I had a bigger circle, but that's it. But what is 2 pi minus alpha? Because from here to get back all to the original point, it's 2 pi radians or 360, huh? But because of the symmetry, this angle, Samantha, is alpha.
Yes.
You see that? I lack that alpha, then I subtract it from the whole angle. Then it becomes 2 pi minus alpha. You got it, Samantha?
No, please try again.
Look at that.
Yeah.
Imagine if you start from this point.
Yes.
This is 0 degree, huh?
Uh-huh.
This is my moving arm. I make the full circle come back to the same point. How much radians did I place?
360.
Or
So
2 pi.
then it's 2 pi. Yeah.
That's right. But I'm not here. I'm here. What is the distance between this point and that point? The distance between this point and that point, how much angle is that? That's
I think
alpha.
it's alpha again because.
That's right.
Oh, okay. Okay. Like, can you hear me when I say it? But then it's like, so it's the big one is 300 minus alpha.
That's right. 360 minus alpha.
Sorry, what?
300. You mean 360?
Yeah. 360 minus alpha.
That's right. It's 360 minus alpha in order to get back to reach this place, because you are missing alpha from the total angle, which is 360,
Mm-hmm.
right?
Right.
Awesome. Then now, how much time do we have? I think we have 12 minutes. I have to be a little bit fast. Now, guys, then you see that as a conclusion, if Ming is standing there, he has infinite number of the brothers who are behaving exactly as Ming. Infinite, maybe 1,000, 2 million. Okay, Ming, but
Okay.
we can see 3 of them here, 3 of your brothers, which they have the same characteristic behavior as you. And now we have 2 methods to find them. If you're at X, Y, and alpha, you can localize the other ones at different places. That's right?
Yes.
Awesome. Anyone, any question?
No, but
No.
just hold on a second. I just take a picture of it, what you write. Okay, there we go. Okay, I'm good. Please.
Are you
please go
good?
on. Yeah.
Awesome. Okay, let's see, what did I prepare else for you? Okay, now I'm just going to talk about, I should say, the reference angles. It is going to be, I assume that you had it for function 11, and hopefully we should be finished by this one. Guys, we use these kind of concepts to also define something which we call that as a reference angle, which is going to be a very crucial concept for the stuff which we're just going to cover. Okay. Guys, you see my paper?
Yes.
I'm drawing the circle. I'm gonna do the first important thing. We call that the reference angle. Reference angles are incredibly important, and the concepts of the reference angle is crucial for whatever you do in the trigonometry. Then I'm just gonna do one of them today for you, and hopefully do the rest when you do the exercises from chapter 1.7. Okay, guys, as usual, the thing which I do is this. I am gonna have a circle and the reference frame exactly like this, X, O, Y. And the thing which I'm gonna do is that I'm just gonna come here to pick up an angle. the angle which I'm going to pick up is going to be this one. And I said that this angle which I have here is going to be pi over 6. Okay. It's going to be pi over 6, which is equivalent to how much? How much degrees? It's easy. You put pi by 1 over 180 divided by 6 becomes 30, correct?
Correct.
And that's going to be my angle. If I look at this one angle, guys, the thing which I see is that I can make a projection along the both coordinates to find the x-axis. It's going to be what? It's going to be my x-axis, x-coordinate, and also I can do the same thing along the y to find what? The y coordinates of my this angle, correct? And I put this angle A. Let's put that A. Okay, everyone is so far good? Okay, now guys, the thing is that I know that if I have, let's say, x and y for the point A, which localizes my point at this plane, then the thing which I have to do is that I just want to just find some numerical numbers for what are the x and y. Because what have I done so far is that I know the angle, but I have no information about the x coordinates and the y coordinates, right? And now my problem here is now that if I have the angle, and if I know, for example, the mean ray is standing at the point A, I know that the mean ray has the angle of 30 degrees. What is x and y coordinates for the mean ray? That's the question which I want to answer. In order to answer that question, I'm just going to come to do what? I'm going to come and make a kind of a special triangle. You know that that's a normal triangle. They call these ones special triangles. Imagine, guys, that I'm going to make a triangle here like this. Everyone see what I'm drawing?
Yes.
I'm going to make a triangle to look like this. I'm going to copy this one. Copy exactly the one which I have there to here. I remove it from here. Then it means that this angle is going to be how much? Pi over 6, right?
Yes.
What is this angle? Normal, 90. What is this angle?
180 minus pi over 6 plus 90.
Becomes 60 degrees, which is essentially pi over 3 radians. Right?
Okay.
And now, the thing which I'm going to do is that, guys, please learn this method. I'm going to give you homework to do with the other angles. Then, when we just want to do that, I say that my special angle is going to be this. I assign this length of the length of this side of my normal triangle to be 1 unit. This one becomes how much? I say that it's going to be square root of 3 unit. That's a kind of a special triangle for our purpose. I make a normal angle like this. How much is the hypotenuse of this triangle then? Square root of 3 and 1. Use the hypotenuse theorem. How much do you get for this? Square root of 3 to the power 2 plus 1 becomes 4. It becomes 2, correct? 2 units. And now, everybody so far, so good?
Yes.
Awesome. Guys, look at this one. Can I just take this one, put it back there? I mean, I remove this one, bring it back there.
You can.
I cannot, because if you remember from, I should say, your lessons from the function 11, which I made the mistake, I forgot to tell you, in the trigonometry, you are working with the unit circles. It means that the radius of your circle is always 1 unit. is 1 centimeter, 1 meter, 1 kilometer, 1 inch. The radius always is 1 unit. But the hypothesis is 2. Then it means that the size which I have is twice as this. Right?
Mm-hmm.
Then it means that I cannot take this one out, put it back there to find this. It means that I have to rescale this. I call that rescaling. How to rescale this? If I divide my hypothesis by 2, it means that I can just make the same hypothesis by 1 from there. Correct?
Mm-hmm.
It means that in order to keep the size the same, I divide everything by 2. If I divide everything by 2, what do I get? I get the hypothesis becomes what? How much? Becomes 1. How much this one? Becomes 1 over 2. How about this one? Becomes the square root of 3 divided by
over 2.
That's right. I rescaled it by dividing by over 2. Pi over 6. And now, guys, if I now take this out, remove this from this, and put it back there, I just essentially did the same thing. Then how much is going to be this length there? How much is this length if I remove this one from here, put it back there? 1 over 2. How much is the x now then?
Root 3 over 2.
Square root of 3 over 2. Correct?
Yes.
Which it seems that we ran over the time. It's almost 11, and I have to continue that tomorrow. Guys, tomorrow we are just gonna, essentially tomorrow is gonna be the very last day that we are reviewing function 11 for the trigonometric functions for the advanced function. I build up materials on this one for the reference angle, which is a very, I should say, important concepts of the trigonometry. Please stay where you are. At this stage, I finished the fact that I got x and y for the angle pi over 6 when the mean j was standing at that point. Tomorrow, I continue with this to finish the review of the function 11 of the trigonometry. But at this stage, please do the assignment of chapter 6.1 of the Nelson book and post it to me online. Okay? By tomorrow.
Bye.
Chapter 6.1 is going to be your homework for tonight.
Okay.
12 questions. If you have no questions, guys, then I see you all tomorrow.
See you.
See you
Have a
tomorrow.
good day.
Bye, everyone.
See you tomorrow. Bye.
See you tomorrow. Bye.
May the force be with you.
Sorry, what?
No, nothing.
Brian, is it you?
Yeah.
What do you say?
May the force be with you.
Sorry, what? Say that again?
No, never mind.
May the forest?
Force.
Oh, thanks. Oh my God, I love that phrase. Thanks a lot, Brian. Same to you. Thanks. I love that phrase. Thanks a lot, Brian. Thanks a million. Thanks. And
See you.
same to you, and see you tomorrow, Brian.
Mm.
Thank you. Bye for now.